Hey, we are joined by Algebra Cowman, and we're going to find the sum of a series. You're like, series? Wait, we've been doing sequences, haven't we? Well, if we add up all the terms of a sequence, we call that a series. Right? List of numbers, sequence. Add up the list, it's a series. List of numbers, sequence. Add up the list, series. Today we're going to focus on the series that have a finite number of terms, right? So like that 1 plus 3 plus 5 plus 7 plus 9, and then it stops. The type of sequence where it goes on forever with that dot, 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 we'll take care of that next class session. Okay, now there's some special notation that shows up when we're going to add all the numbers in the list, right? That's the normal way of saying, hey, let's add up all the numbers in the list. Of course, the mathematician would say, no, we're going to find the sum of the terms of a sequence. And we call it sigma notation. So, if I want to find the sum of the first k terms of a sequence represented by, and that great big weird looking E is the sigma symbol, and it says, hey, we're going to start with n equals 1, we're going to go up to k, and then we're going to have the nth term, a sub n, and I just plug in the numbers 1, 2, 3, all the way up to k. Right? N is called the index of summation, k is the upper limit of summation, and 1 is the lower limit of summation. Now, if that just looks like a bunch of gobbledygook, maybe if we take a look at an example, it'll start to make sense. All right, so let's get an example up here where we're going to actually plug in numbers and see how this works. Okay, so first of all, the sigma symbol tells me I'm going to add a list of numbers. So there's the sigma symbol. It says, hey, guess what? You're going to add a list of numbers. I'm like, okay, I can add some numbers together. Underneath the sigma symbol, it says, hey, right, we're going to use n, just like we have before, right? A sub 1, a sub 2, a sub 3, all the way up to n. And how many are going to be in this list? Right, this is where that k would have been on the previous slide. Well, maybe I want to add up the first 5 numbers, okay? So n equals 1, so start with the number 1. The 5 says, hey, you're going to add up a total of 5 numbers. Now, of course, I need to know what the nth term is. And I say, oh, how about 2n minus 1? Okay, so that's a sub n, right? That's the nth term. Okay, so I'm going to plug in the number 1, and then I'll plug in the number 2, then I'll plug in the number 3, then I'll plug in the number 4, then I'll plug in the number 5. So let's plug in these numbers. When I plug in a 1, I have to do 2 times 1, but then there's still that minus 1. Then I can do 2 times 2 minus 1. And then I can do 2 times 3 minus 1. 2 times 4 minus 1. 2 times 5 minus 1. Whew, right? So I plugged in the numbers 1, 2, 3, 4, and 5. And every single time I plug in a number, I have to multiply by 2, and then I have to subtract 1. Okay, so let's see what these turn into. 2 times 1 is 2, but there's still a minus 1. 2 times 2 is 4, but I still have minus 1. 2 times 3 is 6, minus 1. 2 times 4 is 8, minus 1. 2 times 5 is 10, minus 1. Okay. Okay, so now I got to do like 2 minus 1. Okay, so 2 minus 1 is 1. 4 minus 1 is 3. 6 subtract 1 is 5. 8 take away 1 is 7. 10 minus 1 is 9. Hey, that was one of the list that was on the previous slide, right? 1 plus 3 plus 5 plus 7 plus 9. Okay, if I add those up, maybe I have to count on my fingers, maybe use a calculator. That adds up to 25, so there's the answer. All right, 1 plus 9 is 10, 3 plus 7 is 10, 10 and 10 makes 20, and then there's still that 5, so 25. So there is the answer. Now, sometimes we want just to figure out, well, what is the sigma notation? So instead, oh, wait, I was jumping the gun. Okay, let's do one more like this, and then we'll go backward. Silly teacher, silly teacher. Okay, so we're going to plug in the numbers 1, 2, and 3. How do I know I start with 1? It says n equals 1. How do I know 3 is the last number? Well, there's a 3 on top. So plug in 1, plug in 2, plug in 3. So n squared will become 1 squared. 5 times n, 5 times 1. N squared becomes 2 squared. 5 times n, 5 times 2. And then, of course, it'll be 3 squared plus 5 times 3. All right, every time I saw an n, I had to plug in 1. Then, every time I saw n, I had to plug in 2. Every time I saw n, I then had to plug in 3. Okay, what is this? Well, 1 squared is 1. 5 times 1 is 5. 2 squared is 4. 5 times 2 is 10. 3 squared is 9. 5 times 3 is 15. Okay, so let's see what the three numbers I have to add up are. 1 plus 5 is 6. 4 plus 10 is 14. 9 plus 15 is 24. Right, so those are the three numbers in that list that have to be added up. Right, originally that sigma symbol said, hey, you're going to go from n equals 1 to 3. So there's going to be three numbers in the list. There they are. Let's add them up. And it's going to be, what, 44, if I've done this correctly? Okay, now let's try to go backwards. What if I just have the list, and I'm asked, hey, can you just take that list and rewrite it in sigma notation? Right? You don't have to find the answer, right? You don't have to figure out what they add up to. Just change it to sigma notation. Okay, well, so I start with sigma, right? I got to put a great big sigma symbol. I'm going to start with 1, right? N equals 1. How many numbers are in that list? 1, 2, 3, 4. I count 6. Right? There's 6 numbers in that list, so I'm going to go up to 6. Now, what is like my formula? What's my equation for the nth term? Well, it looks like we go up by exactly 3 every time. Right? 10 plus 3 is 13. 13 plus 3 is 16. 16 plus 3 is 19, etc. So this is one of those arithmetic sequences that we worked with previous lesson. And I said, oh, since it always goes up by 3, I have to have a 3 times n. Now, I can either dig up my notes from the previous lesson and figure out how to do the rest of it, or I could say, you know what? That first number has to be 10. But 3 times 1 is only 3. So 3 times 1 is 3. What do I have to add to get all the way up to 10? I guess I have to add 7. Let's see if what happens if I plug in 2. 3 times 2 is 6. 6 plus 7 is 13. Aha, the second number is 13. What if I plug in a 3? 3 times 3 is 9, plus 7 is 16. Yep, third number is 16. It's working. So that's the answer. Right? It didn't say find the sum. It said just write it in sigma notation. Let's do one more example of each, and then I'll turn you loose. Evaluate the sum. Okay, let's plug in the numbers 1, 2, 3, 4, and 5. So I'll have 1 squared minus 7, plus 2 squared minus 7, plus 3 squared minus 7, plus 4 squared minus 7, plus 5 squared minus 7. Right, so I plugged in the numbers 1, 2, 3, 4, and 5. Let's see, what is 1 squared? 1 squared is 1, then I'll take away 7. 2 squared is 4, and then I'll take away 7. 3 squared is 9, subtract 7. 4 squared is 16, subtract 7. 5 squared is 25, subtract 7. And of course, 1 subtract 7 is negative 6. 4 subtract 7 is negative 3. 9 subtract 7 is 2. 16 subtract 7 is 9. 25 subtract 7 is 18. So those are my 5 numbers I got to add up. So if I add those up, maybe use a calculator if I have to, I get 20. Do you get 20? I come up with 20. Okay, one more example, opposite direction, and then we'll be done here. What if I got a list of numbers? Say, okay, piece of cake, make the sigma symbol. I'm going to start with n equals 1, so that goes underneath. I count 1, 2, 3, 4, 5 numbers, so I put a 5 on top. Now what is the nth term? It looks like every single time I'm multiplying by the number 2, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. Hey, this is geometric. We learned about this in a previous lesson. So the first number is 3. I always multiply by 2. And the exponent is always n minus 1. There's the answer. Right, so you might have to brush up a little bit on the arithmetic lesson, the geometric lesson. Otherwise, let's play with a little bit of Sigma today. So, of course, you're going to have a worksheet. And, oh, what a nice sandy beach to just chill out on, huh? Just bake in the sun. Listen to the waves in the background quietly ripple by. Oh, that just looks so much fun.